A 124 grams rock traveling at a speed of 33 meters per second hit a stick and moves back along its incoming path with a speed of 40 meters per second. What is the impulse delivered to the rock by the stick? If the duration of the stick-rock collisions is 0.0008 seconds, what is the average force exerted by the stick on the rock during the period? I want you to pause the video and see if you can solve it yourself first. What you need to do is you need to create a drawing before, during, and after the collisions. So we have the rock and we have stick. Rock fly toward the stick hit it, and then afterward the rock's going back to the original path. So now we need to capture all the informations in the problems in the drawing. So we have mass of the rock is 124 grams. We have the speed of the rock is 33 meters per second to the right. And then after we have the rocks, during the impact it took around 0.000 seconds, and we need to figure out the impulse on the rock. Afterward, what happened is the rock is moving in the negative direction 40 meters per second to the left. Notice how in the problem up here say 40 meters per second. The reason this minus because going left, we define to the right is positive. Now we're going to bring in some algebra. The definition of impulse is the change in momentum, and then so the impulse on the rock is equal to the final momentum minus the initial momentum of the rock. So we can expand that equation by writing mvf minus mvi. F stands for final, vi stands for the starting velocity of the rock. We can also simplify that algebra by pulling out the m. The rest is just pretty much plugging in the numbers. So impulse on the rock is minus 9.1 kilogram meter per second. So the second part to the question asks us about the average force exerted by the stick on the rock. And again, we go back to the definition impulse again. Impulse is also equal to force times time. I'm going to move up there for some space. And the impulse on the rocks is equal to the average force multiplied by the duration of the impact. And so we divide by t from both sides to put the average force by itself, and the rest is just plug in the number that we already have. And the final solution is minus 11,375 newtons equal to the force. That's pretty much it for this problem. I will see you later.